So let's continue with our naming. Here we just have 7 more examples we'll take, then you can go and name as many as you want to. So this is CH3, COO, CH3. Remember the rule. The first thing is you locate what family is it. Then this is COO, R, COO, R. Of course, that's ester, ESTER, the esters. How do we name the esters? For the esters, RCOR, this part stands for the alkyl part, then this part stands for the alkanoate part for the ester. So naming this one, we have if you want to draw it, C to C, that is 3H. Then you have this C, then you have your double bond O, then you have your OCHR. Let's just shorten it, quickly, or everything. COOCHR. Just very fast. So how do you name this? This is your alkyl part. So this is methyl, because it is just CH3, just one carbon atom. So methyl. Or for convenience, instead of stressing ourselves, we don't need to draw this one structure. That one, COCH3. Just go. This is your alkyl part. Alkyl alkanoate. So you call this methyl. It's like you are crossing it. Then this one is 2 carbon atoms before your O. That is number of carbon atoms after your O and number of carbon atoms before your O. So you have 2 carbon atoms before your O. That is ethanoate. So that makes it methyl ethanoate. Are we good to go? There is no substituent in your chain. There is no other substituent. Now let's go to the second one. CH3, COO, CH, CH2, CH3. So this is complete as well. There is no substituent. How do I know there are no substituents? You see, there is no in bracket either Cl or CH3, so I don't need to elongate the chain as we've been doing. So here, this is the alkyl part, which will come first. This one goes like this. So alkyl part, how many carbons do you have after the O? This is still ester because you have 2 O's and R on the right, R on the left. That's esters. Esters are RCOOR. Your R could be anything. I called it R prime the other time when we were treating molecules. They don't need to be the same R. This can be methyl, this should be ethyl, this can be methyl, this could be propyl, any R. So you have 3 carbon atoms, 1, 2, 3. That's alkyl radical, that is 3, that is prop. That's propyl. Then 2 carbon atoms before your oxygen. Propyl eth, because it is 2. Propyl ethanoate. Moving on to question number 3. You have your HCOOCHR. Of course, this is an ester as well because 2 O's, R on the right hand side, R on the left. You are wondering that why is it R on the left? Yes, it is R on the left. How many carbon atoms? 1 before after the O, that's methyl. So that is methyl. Then how many carbon atoms do you have before the O? That's 1. This one, that is methyl methanoate. There are no substituents because there is no into bracket. See, you don't need to expand it before you know there are no substituents. Now let's move to this. What family is this? You have the family of CH3 is an alkyl radical RCONH2. You should know from homologous series that this family belongs to the Amides family. Amide. So naming it CH3 CONH2. How many carbon atoms do you have? You have 2. That makes it eth. So ethanamide. So that's the family ethanamide. Are we good to go? Now let's take this question. But before we take that, let me add this. What if you have CH3, CH2, CH2, CNH2? Let's take something for instance. What family is this? Since it is not having O, you should know that, or let me just put it as CH2, CH2, NH2. So what family is this? You should know that this family, since it is not having oxygen in it and it is having NH2, this is the nitrile amine family. How many carbon atoms? 1, 2, 3, 4. None in this into bracket, so we don't have any substituent. So 1, 2, 3, 4. This should be butylamine. Butylamine for the amine family. Let's assume there's a substituent. Let me change this to CH3, CH2, CH2, into bracket, or CH into bracket, Cl, CH2. Okay, don't let me complicate things. Let's take it bit by bit. You understand this, right? This is butylamine. Now going on to the next question. That's question number 5. Question number 5. I believe you are still here with me. Question number 5. We have CH3. So let me try to draw this. Since I'm seeing a bracket, it means there will be a substituent. So CH3, that is H, CH in bracket NH2, so NH2 will definitely be here. Then this next C links to this C. 4 bonds, 1, 2, 3, 4. H, H2 links to this COOH. Are we good to go? So expanding this, you have this. So how do you name this? Of course, you are having 2 families here now. And I told you, when you have fights of families, that is, you have NH2, that could be the amine family, and COH, that could be the carboxylic family. What do you do? From the order of seniority we have, if you remember, we have this order yesterday. We know that COH seniors every one of them. So it's seniors OH, seniors NH2, seniors any other family. So definitely you know that the COAH retains, the family position here, while NH2 becomes a substituent. So it means this is the family we are considering. Selecting the longest chain, this is it, this 4. The chain the family is connected to, this is it. So what is this? This is butanoic acid. You don't need to call it butan 1 oic acid, no. But this is carbon number 1. Because where the family is where the family is attached to, is where you know as the carbon number 1. So this is carbon number 1, meaning you cannot name any other thing from the front. Every of them has to take the family's direction. So we are going in this direction. So this is butanoic acid. Now this is the only substituent you have. Hydrogens are not substituents. We've said that a couple of times. So this is the only substituent. What position is it? 1, 2, 3. So it is in the third, carbon, on the third carbon atom. So what name will it be now? NH2, you know it now. It's amino. Amino acid, amino this, amino that. So NH2 is amino on position number 3. That is 3-amino butanoic acid. Are we good to go? So question number 6, you have CH3 in. So C, 4 bonds. H here, 3H, 3H. The fourth one links to this C. These are the 4 bonds. Since there is no oxygen there, so there will not be any double bond. H1, Cl picks the other one. Then you have this C, then you have H, then CH3 picks the other one, then CHO. When something ends with CHO, or properly written, you have double bond OH, 2, 3, 4. You remember this compound, these are the NAL family, alkanal family, the aldehydes. So this is the family, CHO. Selecting the chain that has it and the longest chain that has it. You cannot select 1, 2, 3. It's not the longest. 1, 2, 3, 4 is the longest. Are we good to go? So we select this chain, noting that since the family is found here, this one will be the carbon number 1. Are we good to go? So now let's name the family 1, 2, 3, 4. 4 is but, family al. So that is butanal. So butanal, let's call it butan 1 al. We already said that. So it is butanal. The position of the other substituent, you have chloro as a substituent, and you have methyl as a substituent. But note that you cannot start their naming from the front because the family already has this direction as the standard direction it is speaking. Because the family is going from the back makes the family number the least. That is 1 from the back. So you can't go from the front any longer. So chloro and methyl, 1, 2 for methyl, 1, 2, 3 for chloro. And remember our fourth thing to consider while naming, that is you have to arrange alphabetically. So alphabetically, which one comes first? C or M? C. You're not looking at 3 and 2. Of course, 2 comes before 3. No, you're looking at the lettering, the name of the substituent. So chloro comes before methyl. That makes it 3 chloro, 2 methyl butanal. So question number 6. Okay, that's question number 6. So question number 7, which will be ending this series. There are thousands of organic, compounds. So you just have to find as many. You can go online, just search, give me list of complex organic compounds, let me name, to just test your dexterity. But if you get the explanation so far, you should be able to name as many as you can. If you need help, of course, make people come to tutorial and you would get. But with this, just go through it again and solve as many as you can. You can ask ChatGPT to help you explain whichever you didn't get along the line. So let's finish this. This is CH3 C. Then so let's draw it. You should have C, H here, H here, H here. The fourth bond links to this. This one has 3 bonds. So 3 plus 1, 4. So definitely nothing can be attached with it again. This one too is taking 3 in. Oh, going by this way, the space won't contain it. So let's use just this. So C 4 bonds, H, H, that's CH3. This C takes 3 plus 1, 4. This C, the 3 here, the first one links to this C, H, then in brackets, you should know it is a substituent here, then COOH. Are we good to go? Now let's name it. what family are you seeing here? You are seeing the COH family, and you are seeing YNE. And I told you something that in order of arranging, you should know this family would overcome everything. So we are naming it according to this family. But I told you when you have the double bond or the triple bond, coupled with any of this family, instead of turning to a substituent, you cannot say two ion. No, you blend them. The double bond and triple bond, when they are with another family, they are clipped with it. If you remember the other time, we had butanol. This is butanol, but because it has a double bond, you cannot say OH seniors alkene. So the family is butanol still. They will not say this is a functional group. No, once it is double or triple bond, we clip it with the original, with the family that you have there. So instead of calling this one butanol, you say it is butanol. That is butene and all. But you have to tell us the position of where the double bond is. So since this is the family, this is carbon number 1, carbon number 2. So the bond is beside the carbon number 2. So you say it is but2-enol. Do you understand? So but2 tells the position of this in bond, and this is the family, the all family. So the same thing is what we will do here. So we are going to clip this ion bond, YNE bond, and this family, COOH. So by now you should have gotten your answer, right? You have not gotten it. So what do? COH is the main family here, and it is on this chain as the longest chain. So if they are considering this chain as longest chain, this is iron. I told you will clip it. But let's look at the clipping. 1, 2, 3, 4, 5. This is pentanoic acid. We know pentanoic acid, right? But we want to clip this iron there. So that is pentyne. So what do? This noic, you fix YN in it. See one end, and this is the end. So it means you are bringing this YN here. So it becomes pen 1. This carbon number 1, carbon number 2, carbon number 3. So the triple bond is beside carbon number 3. So first, let's leave the position of carbon number 3. Let's leave the position of triple bond. Let's just name it. So pentyne, it's pentyne and pentanoic. So pentyne, that N is what every the pentyne, you stop it before the end, and oic will continue after it. So pentynoic acid. But we have to tell them the position of where the ion bond is. So that is 1, 2, 3. So it becomes pent3-ionoic acid. Pent3, 1, 2, 3. This Y bond, this ion bond. Why this oic bond is 1? So we don't need to write noi1-oic. No. So just pent3-ionoic. They know the carbon for this acid is the carbon number 1. So pent3-ionoic bond. So we have clipped this and this. Now it remains the substituent 1, 2. So that is, this carbon number 1. So this is 2. So 2-methyl pent3-ionoic acid. So let me make a little modification. If this question had been CH3, C triple bond C, CH3 2 COH. So what would it have been? It's still the same thing. CH3. Then you have C, or let me change it to double bond. Double bond C. So there will be CH here. H, there will be H here. H, 2, 3, 4, C, then CH3, COH. How would you have named this? The family 1, 2, 3, 4, 5. This would be it's supposed to be pentanoic acid, remember, but there's a double bond, and I told you there's double bond or triple bond, you clip it. It becomes pent. What is the position? 1, 2, 3, right? Pent2-enoic. Pent-in, like pent2-in. Then oic acid, pent2-in-oic acid. So pent2-in, they are now adding oic acid, noic acid. So N, this is the N. You take away E, then the N is used to call the noic acid. So that's pentanoic acid. Now for the substituent, let's write it properly. So pent2-enoic acid. For the substituent, carbon number 1 and carbon number 2. So you have two substituents, that is CH3. So it becomes 2,2-dimethyl, because they are the same thing. Dimethyl pent2-enoic acid. If there is OH here and CH3, it will be 2-methyl 2-hydroxy pent2-enoic acid, like that. So here we are. Thank you for listening, and do well to go through it again and revise. May God be with you.